Welcome to Biomedical Gate 22 paper solutions. The next problem number 59 as per the master paper, based on electrical measurements, electrical and electronic measurements as per your syllabus. Let us get into the statements. A moving coil voltmeter, so you can treat this as a PMMC. Permanent magnet moving coil. A PMMC voltmeter, we can say, has an internal resistance of 50 ohms. So let me take the meter as this way. Let me visualize the given statement so that it's easy later. So I have a PMMC voltmeter having internal resistance, the meter resistance that is equal to 50 ohms. Then the scale of the meter is divided into 100 equal divisions. So I have the scale. So going for 100 divisions. Okay. When a potential of 1 volt is applied to the voltmeter, to the terminals of voltmeter, deflection of 100 divisions is obtained. So this is the 0th division and this is the 100th division. So 100th division is my full scale division. So that means it's a full scale deflection. That means what makes full scale deflection? 1 volt is making full scale deflection, means it's a 0 to 1 volt voltmeter. Forget about the divisions. So when a potential of 1 volt is applied to the terminals of voltmeter, the deflection of 100 divisions is obtained. So now 1 volt is creating full scale deflection for the instrument. However, it is decided that when a potential of 500 volt is applied to the terminals, a deflection of 100 divisions should be obtained. That means what? We need to create the full scale division for what? 500 volt. We want to create a full scale division for 500 volt. Yes, is extending the range from 0 to 1 volt to 0 to 500. So he is indirectly pointing voltmeter extension. Simple. The problem belongs to voltmeter extension. That's all. Once you understand this, you know what to do. Then the value of resistance that needs to be connected in series to achieve this in ohms is simple. So you need to, how much voltage you're going to apply? You're going to apply 500 volt. Assume you applied 500 volt for the measurement. That has to create full scale deflection. You have applied 500 volt. Okay, you're going for 0 to 500 volt measurement. You feel like you applied 500 volt. So 500 volt is applied. That means the meter is at full scale deflection, but the voltage across the meter can take only how much? Only 1 volt. Let me connect the two. So out of 500, the meter can take only 1. And so I'm setting the problem at full scale deflection straight away. I'm setting the problem at full scale deflection. So at full scale deflection, the instrument, okay, going to have a full scale deflection by demanding only 1 volt. But we are supplying how much? Means 500 volt we are supplying. That means the instrument cannot withstand 500. So therefore we need to have a bypassing capacitor. What bypassing? Voltage bypassing. So it has to be a series resistance. The potential division should take place. So we need to bypass the remaining potential across this. What is the potential to be bypassed? 500 minus 1. It has to be 499 volt. That's what we call as R series or a series multiplier. The value of resistance that needs to be connected in series is clearly mentioned what you need to do, so that R series is connected to bypass the extra voltage which the meter won't take at the full scale deflection point. At full scale, what's the current flowing through the instrument? At full scale deflection, the current flowing through the instrument is current should remain same even if you apply 500 volt. Okay, what is the current at full scale? So you know the full scale voltage, it is 1 volt and the resistance is already given. So it is going to be 1 volt divided by 50 ohms. That is nothing but, so okay, let it be 1 by 50. Okay, that's a full scale deflection current. Therefore, R series by Ohm's law, you can calculate, that is 499 divided by 499 divided by your current. Because R series also allowing same current through it. Okay, so 499 divided by 1 volt divided by 50 ohms. I'm not taking you to any other expressions. Very simple, common sense in extension of voltmeter. Okay, yes, what do you get then? 499 into 50 ohms you are getting as a series multiplier resistance value. So 499 into 50 will be the answer, but it should be in the value of resistance that needs to be connected. Yes, should be in ohms. Okay, so just calculate 499 into 50. Okay. So 499 into 50 will be 24,950 ohms. So you need to feed the answer as 24,950. So the best answer for this problem is 24,950. D. That's all. Okay. So he didn't say whether your answer must be in integer. Okay. So assuming it's a numerical answer type problem, you have to feed the answer as 24, 950. You're getting a integer number, you can give the integer answer. Okay. So comparing to the other problem, this is also easier. Okay. Yes. Another one. Okay. From biomedical paper, gate 22 from instruments. Okay. Electrical measurements. That's easy relatively comparing to other problems. Yes. So that's how the paper was for biomedical students, and hope you enjoy this content. We'll update you with the next problem. Okay. So thanks for watching. Do subscribe and also share to your friends.